Welcome to my presentation. This presentation is part of the playlist Indefinite Integrals. In this presentation, we will be solving problems using the rules of integration. Let's look at some examples using radical functions this time. If we have a function like this, y equals to integral square root of x to the power of 5 dx, we want to evaluate this indefinite integral. To solve this, we want to know some basic things. We know that square root of x to the power of 5 can be written out as x to the power of 5, the whole thing raised to the power of half. We can express a radical in terms of exponents as shown here. So we can simplify this exponent as x to the power of 5 over 2. 5 times 1/2 is 5 over 2, like that. So we have successfully converted a radical term, square root of x to the power of 5, as equal to x to the power of 5 over 2. Now, we can use the integration process and then simplify this particular problem. We can use the power rule now since we have converted the given problem into an exponential format. Okay, so integral square root of x to the power of 5 dx can be written out as integral x to the power of 5 over 2 dx. We are going to use the power rule now and then simplify this. Integral x to the power of 5 over 2 dx, when we simplify that, we can write that as x to the power of 5 over 2 plus 1, the whole thing divided by 5 over 2 plus 1, plus c. Whenever we complete the integration process, we're going to add a constant of integration c, as shown here. So when we simplify this process here, x to the power of 5 over 2 plus 1, this fraction 5 over 2 plus 1 converts to 7 over 2. X to the power of 7 over 2, the whole thing divided by, we have a 5 over 2 plus 1, again a fraction in the denominator, that also converts to 7 over 2, plus c. Now we can simplify this some more, and then since we have a fraction in the denominator, we can write it to the side of the equation by flipping it over. 7 over 2 in the denominator becomes 2 over 7 on the side of the equation times x to the power of 7 over 2 plus c, where c is the constant of integration. So this is how we can convert the radical terms to exponential terms, use the power rule, and simplify problems using the power rule. Let's look at another example. Let's say we want to evaluate this indefinite integral cube root of x dx this time. Okay. Now again, we want to be able to convert the radical terms into exponential terms and then be able to integrate that process using the power rule. So cube root of x can be written out as x to the power of 1 over 3. Okay, so there is that one-to-one relation between the radicals and exponents. So we want to convert it into an exponential format because we can then use the power rule to simplify this process. Using the power rule, we can write integral cube root of x dx as integral x to the power of 1 over 3 dx. When we use the power rule, we can simplify it and write it out as shown here. X to the power of 1 over 3 plus 1, the whole thing divided by 1 over 3 plus 1 plus c, which is a constant of integration. When we simplify this some more, x to the power of 1 over 3 plus 1, there is a fraction added to a whole number. 1 over 3 plus 1 converts to 4 over 3. X to the power of 4 over 3, the whole thing divided by 1 over 3 plus 1 is also a fraction. 1 over 3 plus 1 is 4 over 3 plus c. Okay. Now we can simplify this since we have a fraction in the denominator. When we bring it to the side, of the equation, we can flip it over and then write it as 3 over 4 times x to the power of 4 over 3 plus c, where c is a constant of integration. This is how we're going to convert the radical terms into exponential terms, use the power rule, and then solve this problem and arrive at the solution. Let's look at another example. let's say this time we want to evaluate an indefinite integral, um, fifth root of x squared dx. Okay, it might look complicated, but it is not. Once we convert this radical term into an exponential term, we can then use the power rule very simply, very easily. So fifth root of x squared can be written out as x to the power of 2, the whole thing raised to the power of 1 over 5. When we convert the radical fifth root to a exponential term, we can write that as to the power of 1 over 5, like that. We have inside the radical term, which is x to the power of 2, and the fifth root we can write as the whole thing raised to the power of 1 over 5. And when we simplify this, x to the power of 2, the whole thing raised to the power of 1 over 5, we can write that as x to the power of 2 over 5. We have successfully converted the radical term into an exponential term. Now we are ready to use the power rule and then simplify this example problem. We can write integral fifth root of x squared dx as integral x to the power of 2 over 5 dx. Now we're going to use the power rule and then simplify this process. X to the power of 2 over 5 simplifies to x to the power of 2 over 5 plus 1, the whole thing divided by 2 over 5 plus 1 plus c, where c is a constant of integration. As you can see here, x to the power of 2 over 5 plus 1, we have a fraction here in the numerator. 2 over 5 plus 1 converts to 7 over 5, x to the power of 7 over 5 in the numerator, divided by, we have 2 over 5 plus 1 in the denominator. So when we simplify that, we arrive at 7 over 5, and then we're going to add this c as a constant of integration to the solution. Since we have a fraction in the denominator, we can flip that and then write it on the side of the equation as 5 over 7 times x to the power of 7 over 5 plus c, where c is the constant of integration. This is how we're going to solve simple example problems related to radical terms, and then using the rules of integration, solve these problems and arrive at the solution. In my next video presentation, we will be solving problems using the rules of integration.